Hello there, I've made this video to clarify a small but important point about gel electrophoresis. This represents a gel poured between two pieces of glass. Before it was poured, a comb was inserted. When the gel hardens up, comb is pulled out, creating these wells. A buffer is added. A buffer is mostly water, but some things have been added to make it conduct electricity very nicely. What is placed in each well? A mixture of DNA fragments, right, of various sizes. So in each well is placed a mixture of DNA fragments. The electricity is turned on and the fragments are pulled toward the positive end of the gel. These are called lanes. So these fragments will be pulled down this lane, these fragments down this lane, etc. The negative fragments are pulled toward the positive end of the gel. So they're working their way through the gel. And so after a while, the electricity is turned off and DNA stain is added, and what appears are some bands. I'll just do this first lane right here, keep this simple. And then I might label these. We'll call this band A, band B, band C, and band D. And so, what will we say are the differences between bands A, B, C, and D? Well, I have students tell me that band D is shorter than band A. Band D is shorter. That means it's not quite as, it's like a little bitty shorter, and this one's wider and longer. No, they're probably all pretty much the same length on the gel, about the same length as the well. That's not it. What is each band? What is in each band? Each band contains thousands of DNA fragments. Thousands. There are thousands of DNA fragments in this band. Thousands in this band. Thousands of DNA fragments in this band. Thousands of DNA fragments in this band. So how come this band's down here, that band's there, and so forth? Well, most of you have the general idea that what type fragment goes through the gel the quickest? The shortest. So these fragments are shorter in length, that's how they got through the gel quicker, than the fragments in this band. And so it's not that the band is shorter, it's that the fragments in the band are shorter than the fragments in this band that went slower. And so this band contains the smallest fragments, thousands of them. This band contains the longest fragments, thousands of them. The fragments in this band went farther and faster, so these fragments are smaller than the fragments in this band. The fragments in this band are smaller than the one in this band, and the fragments, etc. This band contains the longest fragments, thousands of them. This band contains the shortest fragments, thousands of them. So it's not the width of the band, it's the fragments that compose the band. Shorter fragments in this one, longer fragments in this one, and so forth. I think that hopefully gets it. All right, bye-bye.